Let's start. Okay, good. I'm pressing the button. Okay, hello everyone. We are online already. This is Postgres TV special series, which I call Open Talks, where we redo the talks which were not recorded on some conferences and which we consider as a great material. And my name is Nikolai and my co-host is Ilya. Hello.
Hi, everyone.
And our guest today is Amit Kapila, who created a lot in terms of logical replication in Postgres. Hello, Amit.
Hello, everyone.
And not only the replication, yeah.
Right. So I remember your two blog posts related to PostgreSQL 14 development in terms of logical replication. Right. It was very great. We waited this quite long. Previous versions, previous major versions of Postgres, seemed to be lacking major improvements, but Postgres 14 was awesome, definitely.
Yeah. I think Postgres 15 has many more similar enhancements, which some of them I will summarize in my talk today, and I might write a blog also later on that.
Great. Let's then start. I just tell a few words about our channel. So we have those who joined online right now. Please use chat. Ilya and I will be monitoring the chat and deliver your questions to Amit. Also, if you are late and watching this recorded, please ask questions in comments. We will be monitoring comments as well. And also, please use like buttons and subscribe and bell button not to miss future episodes. So, Amit, let's start with your talk.
Okay, so let me share my screen. So let me give a brief introduction about me. My name is Amit Kapila. I am working in databases from past 20 years or so. And in Postgres, I am working for more than 10 years now. And I am a PostgreSQL major contributor and committer. Today, and I work for Fujitsu as senior director, where I manage the open source team and also consultant to their proprietary product based on Postgres. So today I am here to talk about past, present, and future of logical replication in PostgreSQL. So today the main contents on which I am focusing is high availability and scalability solutions, evolution of logical replication in PostgreSQL, logical replication then in PostgreSQL at a high level, then what we can expect in Postgres 15 and beyond. And then in the end, I will try to summarize by giving some ways to build the multi-master solutions on top of current PostgreSQL logical replication. So let's start with it. So the first thing I'm going to talk about is high availability, the present high availability and scalability solutions available for PostgreSQL and otherwise. So the main idea initially for high availability is to set up the master and standby system where the data is replicated between master and standbys. And if the here in this topology, the only write happens on the masters and all the reads happen on the standbys. So the basic idea is if master goes down, we will promote one of the standbys who is more near to the master in terms of catching up, and we will make that as a new master. So this is a very basic idea of how high availability can be achieved, and this is available in PostgreSQL as well. So now such a solution can be scaled by routing reads to standbys. but still for multi-sites, like different geographical locations, write still node to go to the master, which is very time consuming. On master node failure, there could be a time lag to promote standby, because it is a read replica and it might be lagging than master. So we need to apply all the wall before it can accept the new write request. So you can reduce this time by setting up synchronous standby for the physical replication, but still there will be quite some lag. And then even after you promote the standby, it is quite possible that there becomes two masters in the system, which we commonly call as split brain. Like the old master also becomes available, and the new master also is there. So all such, I would say there are some advantages, some disadvantages of this scheme, and we would like to see how the other solutions compare to this. So then there is a common another solution which is based on the shared storage, which has all the nodes as master nodes. Like writes can be performed on all the nodes, but all the modifications are done on the single shared storage. Now, the beauty of this is that if one of the node goes down, the writes can still continue, unlike the physical replication, which we have seen in the previous solution, where we need to promote it, the standby as new master. So here we'll see the zero or minimal failover time, and multi-site writes can take more time because of a lot of synchronization is required to modify the database resources, which can sometimes limit the scalability of the workloads. But this is primarily a high availability solution. It could be used for high availability. And Oracle RAC is a typical example of such a system. Then we have a master with separate storage kind of solutions, which we commonly call as shared nothing kind of solutions. So here writes can be performed on all the nodes, and modifications are performed in separate storage and can be replicated to other nodes. Now, like previous solution, here also if one node goes down, writes can still continue on the other node. And the multi-site writes can take slightly more time because of the synchronization effort required, like all the data needs to be replicated among all the nodes. In this, like another kind of problem that can occur is a conflict, which means that like on both the nodes or on the different nodes, the same data could be inserted. Like for the primary key, there can happen a conflict due to the same value inserted from the various nodes. So such kind of things need some solution, conflict resolution, and would also sometimes need manual intervention. So this is another kind of solution. I think Postgres logical replication could be built towards a multi-master solution by such a mechanism. Now, here split brain won't be a problem because all the node you can write at any node, and here you can distribute your both reads and writes among various nodes. So one advantage is if you can segregate your data based on your nodes, like then it can scale as well. Like your reads and writes could be much faster. Now, some other use cases for such a solution, which is like mostly the logical replication use cases, like sending incremental changes in a single database or a subset of database, which is unlike master standby physical replication where all the data is sent. So similarly, consolidating multiple databases into a single database for analytical purposes, and then replicating between major versions of PostgreSQL. And with respect to security, also we can give access to replicated data to different groups of users. So now till now I was talking primarily about the journal high availability and scalability solutions for the databases. But now I will talk about how the evolution of logical replication has happened in PostgreSQL. So it started, I think, before 9.4, but in 9.4 is the time where somebody could actually do something meaningful by using PostgreSQL based solution, which is where we have introduced logical decoding, replication slots, and replica identity. So till here, some users can write their own output plugins and build the replication solution on top of it. And then with 9.5, we came up with progress of replication and replication origins and commit timestamp. And then we come up with some generic wall message for logical decoding. I think the general purpose is for outside solutions to build better multi-master or bidirectional replication solution using these features. And then with 10, actually, we came up with the main feature, which is logical replication, in-core replication, logical replication in PostgreSQL. This was a major milestone for logical replication. But over years, then we have enhanced it. Like in 11, we allowed replication of truncates and reduce the memory usage. Then we allow replication slots to be copied in next version. Then we allow replication of partitioned tables and the data which we can keep on any node by using max slot wall size, and some memory control mechanisms so that the memory doesn't increase while doing logical replication. Then with 14, we see a lot of features which really make it the in-core logical replication being really considered for large customers, like streaming of in-progress transactions. Before that, we only allowed transactions to be streamed at commit. Then we came up with some monitoring views. And then we have allowed decoding of prepared transactions. And then we have improved the performance of transactions where there are a lot of DDLs. Then we also allowed transfer of data in binary mode. And similarly, we have enhanced some syntax to add or remove publications for the ease of users. So this is how the logical replication has evolved till now. And going forward, I will explain how or tell how it has improved even in PostgreSQL 15. So till now, any questions? I think we can handle any questions or anything anyone want to discuss in between rather than at the end.
Yeah, I have a question. Like, I'm trying to understand, like you started with multi-master options. So does it mean that further development of logical replication will be like targeted on multi-master? So like, is it framing future development or current development of logical replication?
Yeah, I think there are a lot of people who are interested in developing multi-master solution. I am not sure that the PostgreSQL in-core solution will accept all the multi-master improvements, but definitely I see a lot of traffic related to this area in PostgreSQL. Like we have already proposals for DDL replication, parallel apply going on.
Mm-hmm. Okay,
so
thanks.
I see definitely the lot of improvements happening over years for this, but when can we see actual multi-master is still a question, and whether community will accept it or how it goes, we'll see.
Okay, thank you.
So next we will talk about logical replication in PostgreSQL. So here I will explain the basic mechanism how the logical replication happens in PostgreSQL. So the basic idea is that the replication happens via two background processes, one on the primary database, another on the standby database. So standby database here we call it as subscriber, and primary database we call it as publisher, which publishes its changes to subscriber, and subscriber gets those changes and applies to its own database. So now what happens is that when the data is written to the database, we write it in the wall as well, and wall sender in the background gets a signal that some data is written, and it keeps reading the wall, and via the output plugin it sends the data, that physical data, convert the physical data into logical statement and send it to the subscriber, where in the subscriber we have a receiver of the data which keep on getting the data and apply it to the database. So here we can easily see that even the data can flow in both the directions. Like basically you can even set up this, that the data written on the standby database subscriber could be get back to the primary database as well. So that's why both the nodes have read-write capability. So this is how the basic things happen prior to PG14, where we, at the commit time, we decode the wall and send it to the subscriber side, which gets it and apply it to the database there. So now such a solution works, but for very large transactions, there is a very big apply lag, because we try to start streaming the data only at the commit time. So with Postgres 14, we came up with the idea where we could even stream the data of the large transactions when they are running, when it exceeds certain memory limit. Now, there are multiple advantages of it. Like sometimes the data is not published to a particular subscriber. In that case, we can quickly discard that data rather than allowing to spill it to the disk for large transactions. And we have seen that this saved a lot of IO, and the performance of such a thing has improved by 2 or more times due to this. So some of the enhancements which we have to do to allow this were like I have told, that we can start streaming the transaction data once it exceeds certain memory limit, which is, we call it as logical decoding work mem. And now, because that one transaction can have the sub transactions, we need to associate all the transactions and sub transactions before the commit time. So that technology has been built. And then we also need to process invalidations at each command end rather than at transaction end. So these were some of the building blocks which has helped us to allow incremental streaming when for the large transactions. So this has been explained in a very simple, with a simple diagram. Like you can see, when in this there are open streaming block and closed streaming thing. Like all the changes have been divided into chunks where start and close stream, which are encoded by start and close stream. So this way we can divide the data of the transaction into smaller chunks and send it to the subscriber, which as of now till 14, it spills all the data to the disk. And then only when the commit comes, it applies to the database. Now here, definitely you can see the improvement which could be done is that as soon as we get the data of this first chunk, we can apply it to the database via some background process or something. And that is the technology which we are building for the next releases. But this also saves us the time for network delay, which could be introduced because we were sending all the data at the commit time. So then there are like multiple. Sorry.
Sorry. Can you explain once again about this background? I think you mentioned, like, is it on subscriber side or
subscriber side? So Nicola, we can see
what problem does it solve?
You can see that it will further improve the lag. Like right now, there is a lag again on the subscriber side. What happens is that you get the data in the chunks on the subscriber, but you apply only at the commit time. You keep the data, just see the temp in some temporary file or temporary space.
I see. Understood.
So it should be applied immediately, but that needs another technology that we could hand over that data to some worker and keep getting the new data and then apply it in parallel.
Right. Also, on this picture, another problem could be that val sender it's a single process, right? So it needs to process all records in val.
I think you mean applier, so that's much worse actually.
Usually yes, but I have a case when it was like if, for example, if on this picture we replace insert with delete and commit we replace with rollback, so we just generate a lot of massive deletes and roll back them immediately. On applier we don't need to do anything because these transactions were not succeeded. So but on val sender we will see a lot of work to read the val and translate it and then decide that it's not like nothing to do. And like in our cases, like I saw on quite modern software, like we can have many cores, but it's a single process. So we see only like 2 vals per second already our limit. It's very low. Like 2 vals, it's like if it's 16 megs by default, it means that 32 megs per second, not too much. Right, but it's very different topic actually. I'm still in the agenda, sorry.
Yeah, I think right now we are still solving the problems of apply side to make the apply faster, because apply side more work is there. You have to write all the data to the database and then populate the indexes. All that stuff is need to be done.
Right.
The actual work is much more, but definitely, as you are telling, where there could be a more load on val sender as well for smaller transactions which gets aborted frequently.
Okay.
True. So here we have to support streaming of in-progress transactions. We have to extend the logical replication protocol to identify in-progress transactions. And then we have modified the output plugin to implement the new stream API callbacks by leveraging the extended replication protocol. And then, as I have explained in previous slide, we have modified the apply worker to stream such in-progress transactions and spill the data to disk and then apply all the data on the commit. So we have provided a new option with streaming on while creating a subscription. So this feature will be enabled only if user uses this option. So now this is about logical replication and some of the very big feature we have developed in PostgreSQL 14, which I have explained. I think the real things come where we'll talk about what is lie in the future, like Postgres 15 and beyond. So I would like to say here is that all of this is yet not released, and the Postgres 15 part is already committed, but it can still roll back. It can still be reverted or might need a change because of communities reviews or testing. And the work in PostgreSQL 16 and beyond, it will be just at the proposal stage. So nobody can comment whether we will see that in PostgreSQL or not. So I think one of the features I like for Postgres 15 for logical replication is now it will allow the in-course solution for logical replication of prepared transactions. So as compared to the previous slide here, you can see that we can now send the data at the prepare time itself. Earlier, it was always sent at the commit time. So there are multiple advantages here. First one is that it also reduces lag, because nobody knows the time difference between prepare and commit. So unnecessarily, the transaction is not sent to the subscriber till that time. But a bigger advantage I could see, we could build a technology where we could build a conflict-free logical replication, such that if at the prepare time, we can see that there is a failure at the subscriber side, we can actually allow to roll back that transaction. So there will never be a conflict, right? If there is a conflict, we'll get the failure and the vault sender could also roll back such a transaction. So now this could really help in building the conflict-free replication, apart from its advantage of reducing the two-phase transactions. So yeah, I think this is mostly what I have told. Like it will help us to build conflict-free logical replication, because if there is any conflict, say primary key violation, then the prepare itself will fail. The next thing is a logical replication of schema and sequences. Like it has a very similar syntax as compared to our current publication, where user can specify all the tables in schema with schema name, and similarly for sequences. Now, what will happen is this will allow us to easily publicize the data which we want to send to subscriber. Instead of, say, if we would have prior to this, the tables from the two of the schema in the database only needs to be published. Users have to manually type all the tables, which may not be a very frequent use case, but in those cases, it would have been really a very tiring job for users. But this will allow users to, easily use this feature. Like now, and for the sequences, it will help to reduce the manual intervention by users, where they need to keep sequences in sync. The sequences is still not committed for Postgres 15, but we'll try to do in the later releases this work.
So it was decided already to postpone, right?
Yes.
It's a pity. It's a
we have. Sorry.
Long-awaited feature, definitely.
Yeah, we have tried a lot, but we came up with some design challenges which needs more work. So the very interesting feature for Postgres 15 is row filtering for logical replication. Now, like when we subscribe the table, all the data of the table needs to be published, and it is like retrieved by the subscriber and applied. With row filtering, we can actually, just send the selected data we want. So this will could be used to improve the performance, and also users could do sharding based on this, and then it could also help in keeping the security intact, like don't send some secure data to some of the subscribers or something like that. And we have seen that it improves the performance proportional to the number of rows that got filtered, which is really another benefit of this feature. And similar to this, there is a feature, column lists for logical replication. Here, instead of sending all the columns of the table, we send only selective columns of the table. So such a restriction helps when the source and target table doesn't have the same columns, or some of the columns in the source table have sensitive information. So this again, I would say in independent, it won't be a very big feature, but with row filter and column list together, it really brings a new opportunities in logical replication for PostgreSQL users. Yeah, now I'm coming, before going to next topic, I would like to see if anyone has any questions, or Nikolay, you have any question?
No, not this time.
In chat, not at this time. Yeah.
All clear. Of course, I have questions about, for example, you mentioned that I was surprised to see in previous slides that it was allowed to copy slots already in Postgres 12. I somehow missed it.
Yeah.
But like, it's still like it's low level thing. Like still, if failover happens, I mean physical replication failover happens, we lose slots by default. And
yes, definitely.
It's a big problem also, right?
Okay, I am going to touch that in slides.
I also have additional questions about it, but okay, later.
Yeah,
okay.
That is a very in demand feature, and
sure.
We are still not able to get that committed. That's a shame, but yeah, we are working on it. It's not that community doesn't know about that.
I know some unofficial implementations, for example, in Patroni supports it, but right. Okay.
But, I think it is difficult for me to comment on their solution because I haven't looked at it in any detail. But I know that many various companies also provide such a feature for their customers, which is good.
Because it's really needed, right?
Yeah, but now it all depends. Like we are not able to come up with a tight solution which doesn't break or which doesn't have any race conditions. So that is the situation where we are.
Okay, thanks.
So next, I'm going to touch a very interesting topic of logical replication, which is conflict resolution. Yeah, it is quite common, or it is well known that conflicts can happen in such a solution. I have explained that in brief in my initial slides. So basically, let's take some examples. Like when we are applying the changes on the subscriber, if there is any constraint violation, say primary key, then the replication will stop. This will refer to as conflict. So this is a big problem for users. Normally, they need to, at least as of now in PostgreSQL, they need to manually remove that data by checking in logs, or they need to use some proprietary solution which provides some way to avoid conflicts, or give conflict handlers. But with PostgreSQL, we have before Postgres 15, we have basically two ways, like by manually removing the conflicting data or by skipping the transaction via PG replication origin advance. So PG replication origin advance, what it does is that it advances the wall location on the subscriber and it starts replaying from another transaction. So you can skip the whole transaction data due to that using this feature. But it is tricky to use because getting the LSN till where user wants to skip is not very straightforward. And then users will be allowed to skip with Postgres 15. We have came up with a feature where users will be allowed to skip the conflicting transaction by specifying LSN of the conflicting transaction within SQL syntax. I will touch upon that later. And also we will store the error transaction information, more transaction information in the server logs, which can help users to easily identify conflicting transactions and get the LSN till which they want to skip. For the situation that retries cannot possibly succeed without human interventions, user will be allowed to disable the replication automatically on conflict. So this is yet another feature we have added to logical replication, where we'll automatically disable the replication if the conflict happens, and provided user has set that parameter. So we have introduced a new system view, PG stats, subscription stats, which will show the information about the errors, like how many errors have happened during application of logical replication changes. So in the future, we can extend this view to track other ZAC related information like number of ZACs committed, aborted for a subscription. As of now, it primarily stores the error number of errors happened in the subscription.
I think such view should exist for all errors in Postgres.
Yeah,
not only for replication.
This is for apply errors we are talking in particular.
Yeah, I understand, but it's like it's a side note, because like we need to process logs all the time, and we don't have internal view. There is extension from Yandex which called log errors, which provides this functionality to track errors by different, like by error code, for example.
Oh, okay.
So
Okay.
what you created probably will inspire someone to think about all errors, right?
Yeah, right. But this is at this stage, it is mostly about logical replication.
Of course, right.
And the way it is enhanced, it is not only about error. We might want to store some other commit information also, how many transactions committed or something like that, based on the use cases and the information we get from users, what they want also. So the key information here is the number of times an error occurred while applying the changes, or number of times an error occurred during initial table synchronization. This information is all for each subscription. Now comes to the interesting part where I have talked about the skip of the conflicting transaction. So users can see, the interesting part is here, like if any conflict happens, say primary key violation, user will see such a message in the logs. And here you can easily see that this transaction has finished at this LSN. So this transaction has generated a conflict, and this is the LSN where this transaction has finished. So what users need to do, if they cannot manually resolve it, they can use alter subscription skip LSN and give that LSN, and it will just skip the that transaction apply, and the replication will continue from there. Does it make sense?
Yeah, it makes sense. I'm just trying to understand like use cases and like it may happen that like storm of such commands will be needed. I mean, a lot of them.
No, I think
maybe.
Normally only once the transaction fails, we don't proceed. So
yeah, I understand that.
Yeah, but you are right. It is possible. Like if you skip the one transaction, other transaction came, that also leads to some other conflict. Yeah.
Yeah, because if we had a lot of inserts and we already have them, it will be like we will need to skip many of them. But it's still very convenient otherwise.
Yeah. Then as compared to the earlier stuff, which is PG replication origin advance.
It adds flexibility anyway. Like choices. Great.
So next comes some miscellaneous features. Like this is the feature you were talking about, logical replication from physical standby. So this hasn't happened.
I didn't talk about. Sorry, I didn't talk about it, but this is even better. If like, it's very related, right? So if we need to, right now we can do it only from primary, but if failover happens, we lose our all logical slots, and it is a problem. But this is even better because if we can move our logical slots to standby initially, it's even better because it allows us to load balance this load, like to use multiple standbys for logical decoding of different tables, for example. So we can distribute this load from the primary, and this is the same way as we distribute selects, for example.
Yeah, I think definitely. So this is another thing. But the first case is, you are right. I think both the cases will support it together. Like the first case we have to support is allow the physical standby to be used after failover. As of now, that is also not getting used. Then we will allow subscribers to connect to physical standby for existing publications and get the data. So this feature will also provide a way to continue logical replication after the standby is promoted as master. So I think the point is we are, this feature has been discussed and being discussed still. There are some design issues which are being discussed in the community, and Postgres 15 doesn't have this feature for sure. We'll see how soon or when we'll get this feature. But Postgres 15 has another good feature where we allow non-super users to apply the changes on subscriber, provided they have permission on the required objects. Prior to this, only super users would be required to apply the changes on subscriber. So some of the features which are being discussed but not very actively, or some are now being discussed, started being discussing, are DDL replication. Like DDL replication is one of the major features which is, you can say, still not supported by PostgreSQL, and most of the users need it for various purposes, whether it is online upgrade or initial setup or blah, blah, blah. So then we have a conflict detection and resolution handlers. There is, as of now, no discussion for this, but this is also a very good feature which is missing in the Postgres. Then we have parallel apply. This feature is also being discussed. Then we want to also implement bidirectional replication of the same table. As of now, if user implements try to use this, there is an infinite recursion in the system. So currently it is not in a usable form, but this is under active discussion for next release. So next, before going further, I would like to see if anybody has any questions.
I have two questions here. First is what we discussed this on previous slide. Logical replication from physical standby. There is another idea I didn't see discussion. Probably I should raise one. What do you think? Is it possible to logically decode walls which we already archived by archive command? I mean, we have wall archive. We could receive walls from there and decode them, right?
On standby?
No. We have just one node. And we have an archive command which sends wall to archive. To S3, for example, on AWS. And then we extract this wall on separate server, and we could like logically, we could decode and apply on this, like in this case, we would not disturb production cluster at all. Not even standby. It's exotic, I guess, but still, like, why not, right?
I think because it won't be easy for us to build the snapshots for those archived walls. Like you need to decode, for decoding, you need to build the snapshot, like which all wall needs to be sent based on your publication. So it is not that we don't start at the random location to start sending it. We need some consistent snapshot from where we send the wall. Like basically a transaction couldn't be started from the half to get it sent to the subscriber. So all such technical problems could be there.
Okay, if you touch this topic, one more question about like synchronization. Usually we have like initialization phase and then CDC phase, right? And we need to understand where, like for CDC we need to synchronize these phases. And I noticed that if we use replication protocol when we create a slot, it returns snapshot name, right? So, but if we create slot using SQL command, it doesn't return it. And I noticed some proprietary technologies, very popular ones, which use SQL to create slots, and they don't understand that they have opportunity to synchronize. So they say, you know, in some cases, if a subscriber doesn't have primary key, you will need to deal with duplicates. Why? Because they use SQL query to create slots. And they have overlapping CDC. Right. And this is just because they didn't reach this alternative way of slot creation. And I wonder why SQL, like maybe it's a small improvement, could be like a SQL command also could return slot name, right?
I don't see why not. Maybe I am also missing something, but if you raise the question, I can check.
I will do it definitely. Okay. I had one more question, but I forgot. I will do it later after multi-master topic.
So how we will build the multi-master solutions of from this logical replication? Sure, it is not in core, but and outside people can use these publication subscription commands with some care, with some technology help from some Postgres people. They can build it. So there are two approaches where we could build the logical replication. This multi-master solutions, which help users to achieve better high availability and in some cases scalability as well. So in the first way, users can build multi-master based on like there will be n copies of the data, whereas like each node's data will be replicated to another node, right? So in this case, there will be like lot of network overhead, but the multi-master solution could be built like in this we can allow the writes of table 1 and 2 to be sent to data node 1, and for table 3 and table 4, we can allow the data to be sent to another node. So yeah, definitely we need some coordinator node which redistribute these writes, and then those will be replicated to another node. So even if one of the nodes go down, you can still continue because the data is completely replicated. So any table data can be read from any data node. For multi-site data can be written to the nearest node. So this is a very basic idea of how the multi-master solution could be built on top of it. As we can see, all the data is replicated to all the nodes, which in itself is overhead both network and latency wise.
I have a small question about this. So basically, many people from my experience quite frequently have a very typical problem with logical replication, which is like somebody fires something wrong on the primary, so basically alter table or something like this, which breaks the logical replication. From your point of view, is there any chances that such a bidirectional logical replication solution could be somehow protected from those things? Because for multi-master system, it is actually quite critical to be stable.
I think the basic idea is we should support the DDL replication. Because once alter table is supported, then you can always, that kind of thing could be replicated. But otherwise, I am not able to see any, straightforward solution for this, other than once the conflict or error is noticed on the subscriber, users need to manually fix it.
So yeah, basically, in some cases, it's like obvious idea to put some triggers on the primary just to forbid some sorts of schema alters or something like this, which is actually looks like a Sloaney replication in its good days, and it's really, really complicated.
Yeah, but it won't be so easy because you don't know which tables we should stop, or maybe if user has a information of publication or subscription, they can put up some triggers like that.
And basically it could be even more, because okay, let's imagine we have all the DDL already replicated. So we have this functionality. Quite theoretically, a smart database user can still issue DDL things which would be breaking logical replication. So I don't know, changing some access privileges to some objects which would stop effectively replication.
I think I agree that there could be n number of things which can stop the replication even after implementing DDL replication, and probably even when DDL replication is implemented, it will be like restricted to a certain thing. So definitely some smart users or DBAs are required to overcome these challenges. And I am expecting it will be taking years for us to reach there, to build everything conflict free.
Yeah, because it's like I don't think it's the issue of implementation. It's just the idea of replication that would be definitely some conflicts, or some things would be well, so to say, forbidden. Yeah.
Or maybe some once we have conflict handlers, maybe there we could try to see if we can do something.
Yeah. or maybe some sort of like a separate schema which is supposed to be replicated like this with some limitations on types of SQL you can run on that.
Yeah, I think it is a great topic, and but we are
but
still far.
It's a huge one. Yeah.
Schema changes are always a great topic.
Yeah.
A lot of issues always. So okay.
So
Yeah.
coming back to here, now here the challenge is that all the data is replicated to all the nodes, but we could also come up with a better solution based on the use cases where we will not replicate all the data to all the nodes, but only to one of the nodes. Say, like earlier, the table 1, table 2 data goes to data node 1, 3, 4 goes to data node 2, but they don't go to each other. They just go to one single node. Now, you can see here in various cases where the data is sharded well, it could easily be enhanced to a system where we could distribute the writes and reads both to data node 1 and 2 and scale it. It is slightly better than the previous solution because now all the data needs to just be replicated to one node rather than, say, if there are n nodes replicating to all the n nodes. But again, this has its own limitation, like single point of failure and something like that. But this could be another topology where users whose application is sharded aware, basically where it knows which table goes to which node, maybe a bit better solution could be built. So more or less these, I have tried to capture the comparison of these, like first, the number of data copies will be equal to number of nodes in the first solution, whereas it will be total data distributed across nodes plus only one copy for supporting the joins. Then single table read from any node, whereas here in redistributed solution, coordinator will identify the data node and route the query. Multiple table reads can happen from any node in first solution, whereas it will need to be routed to the special node, which is data node 3 in this case for the joins. And single table write could be done to any node, whereas in the second solution, we need to identify and route it to the particular node. So data is synced to all the nodes, which is quite costly, and data is syncing to one node in the second solution, which could be a bit cheaper. And coordinator support is required for both, but maybe enhanced coordinator is required for a distributed database with bidirectional replication solution. Database visibility, it will be generally slightly older as database replication will need some time unless synchronous replication is used, where all the data is visible at the same time. So conflicts can happen in both the solutions, and scale up depending on how we implement. It doesn't require much downtime, and scale down in first solution it requires downtime, where doesn't require downtime, whereas in the second solution it may require downtime because we have the data distributed among nodes. So this is all from my side, and I would like to hear your opinion, thoughts, questions.
Yeah, this is the last slide is definitely, and two slides are definitely interesting. This idea, I even didn't think about it, like combination of like sharding plus like kind of multi-master. You call it bidirectional logical replication. Did you see such architectures in like in production? I mean, like
no. This is even I have not implemented. This is just my thought. like how one could use based on its use case, because it is not quite uncommon that where people talk that application aware sharding solutions, where applications are sharding aware. So if such applications exist, we can probably build such a solution for such applications.
I think here we will have a question about control of the lag, right? Because if you want to send the joins to this common database, data node 3, the question is how, like, since it's based on it's a logical replica itself, right? So it can have some delays, right? So, but the general question is like, what happens if we see the lag is increasing? What to do, right? What our options? What our options are?
This is what I have captured, like in data visibility. If you don't want your data to lag, you can use synchronous replication. I don't think there is any magic solution other than that.
Right. But there is no such thing as synchronous logical replication. It's always asynchronous.
It is there. By default, it is not enabled, but you can enable
right,
the
yes.
synchronous.
Right. But okay, interesting. Okay. So I forgot my additional question. Maybe Ilya has some questions.
Yeah, it's actually quite an interesting talk. So I would say, was it changed your ideas? So you are practically quite long with logical replication, yes? Then you started to work on it. What was your ideas how logical replication would be used? So what was the evolution of your view of the future of logical replication during this significant amount of time?
Yeah, I think it is primarily from the idea that there are basically two ways. Basically, I treat it as mostly a high availability solution like Oracle RAC. So in Postgres, why I have started working on this is, and how I am evolving is, like, this was one of the main areas where I could see that if the more effort is put, it could take Postgres to really next level. Or at least this is one of the most demanded features where we could improve logical replication, have some multi-master solutions. Even if we don't have, the idea is, even if we couldn't implement everything in core, the more features we have in core, it will enable people to write their own solutions in an easier way, rather than everyone having their own features, such features. And I probably see that it is going to evolve further in this direction. Like, as I have told, to support a very big features like DDL replication, parallel apply, bidirectional replication, conflict detection. These are very, very big things, which will, I think, take a couple of years to get us there. So we want to evolve like that. And if possible, we will see how multi-master solutions could also be, built.
Yeah.
If we talk about a little bit, can we talk about a little bit about this performance issue? So I noticed, like, if we generate these rolled back transactions, deletes, I saw the limit on some AWS instances, quite powerful ones, like 2 volts per second maximum. So, and also, as I know, like, but it was with default decoding plugin. As I know, somebody told me recently, I never tried myself, but somebody told me that Vault2JSON plugin, which is like additional one, not in core, Vault2JSON, it allows you to skip some records in Vault. And so you can say that these tables are in this slot, and those tables are in the second slot. So you can split the work between two Vault sender processes, right? And this allows you to to have a lower limit for performance. We still should test it. I mean, in our team. But what do you think? Like, I see it's a big problem. Do we have in Postgres? Do we have some performance tests which will show us this limitation of wall sender?
I don't think Postgres in itself has tests, but one could build such tests, and I am pretty sure that it will have some things like what you are telling, because each wall sender normally decodes the wall. So,
everything, right?
Yeah. So first of all, that is the big challenge which could be overcome. Like, not all wall senders need to decode all the data, right? So we could use some shared memory technique or something to save that effort. I feel that would be much more bigger saving in terms of wall sender, rather than just focusing on the particular use case of rollbacks.
Okay, I can raise this question in Hackers too. I have some test in hand already, very basic one, which shows this limit easily. So I promise I will write to Hackers.
Thank you.
Yeah, sure, definitely no problem at all. Okay, so it was very interesting. If I don't think we have any more questions. Yes, so thank you so much, Amit. It was very, very interesting. I hope all ongoing development will succeed and will not be postponed for years, because like people need it definitely. I know such people, know several companies who will benefit from this ongoing work. And I definitely have new ideas to think about in terms of multi-master, which I didn't have before this talk. So thank you so much.
Thank you.
And to Ilya, you're muted.
Sorry. Yeah. Thank you, Amit. It was like very comprehensive talk, I would say, with lots of technical details. And yeah, I hope that this work would be progressed as fast as it is progressed now. So it's basically very good parts of the Postgres, and it tends to be quite unique now. So it's like already much more than in many databases.
Thank you. It is really my pleasure to speak with you people and giving presentation here again. Thank you for giving me the opportunity. Thanks.
Yeah, recording will be available, so you can. I will send you a link, and please subscribe, leave comments, like this video, and see you next time. Thank you so much. Bye bye.
Thank you.